2 is on circles. So all of Chapter 8 is on conic sections. So we talked about what conic sections were last time. So we can have circles, parabolas, ellipses, hyperbolas, we can have all those different things. So the first thing that we're going to do are circles. Okay, and all conic sections are defined by distances. So the definition of a circle, which I think you guys get, is a set of all points in a plane that are a fixed distance, called the radius, from a fixed point, called the center. So if I have my center, I have an infinite number of points that are the same distance away from that center, right? So that distance is called our radius. So if I draw all those points in, I end up getting a circle. Not a very pretty circle, but. So number 1, so it says write the equation of the circle with center at -3, 4 and radius of 6. Okay, so this is going to be kind of weird how I do this, and then I'm going to show you a formula that will work for all of these circles. Okay, so don't do it like this on your homework because I'm going to show you a way to do this, but it's not very hard. So let's look at this. So if I have a center at -3, 4, and I have a radius of 6, I want to have all the points that are a distance of 6 away. So it could be a whole bunch of points. I mean, there's an infinite number of points, right, that are a distance of 6 away. Okay, so any point along the circle, I want to be very generic with it. I want to call it x, y. And I'm going to use the distance formula to relate the center, -3, 4, to x, y. So I want to talk about this distance, which is 6, and I want to connect those 2 points. So our distance formula, if you remember, was x2 minus x1 squared plus y2 minus y1 squared. Okay. So what I want you to do is we're going to plug in for x, y, we're going to plug in our x2, x1 as xy. So I'm going to replace that x2 and I don't know, I did that, x2, y2. I'm going to replace my x2, y2 with x and y. Okay, so I'm going to have x and y here. And then I'm going to replace my x1, y1 with the -3, 4. So I'm going to have minus a -3, and I'm going to have -4 like that. Okay? And that's going to equal my distance. Well, what's the distance between any point along the edge of the circle to the center? It's 6, right? It's the radius. So that's going to equal 6. So when I do this, I get 6 equals the square root of x plus 3 squared plus y minus 4 squared, like that. So if I'm lazy and I don't want to type in a square root every single time, if I want to get rid of that square root, what do I do? I would just square both sides. So when I do that, my final equation is going to look like x plus 3 squared plus y minus 4 squared, and it's going to equal 6 squared, which is 36. That's going to be what we call the equation of the circle. So I want you to think about how these numbers are related to the things we have in the picture. So what was the 36? What was that? It was our radius squared, right? Yeah. What about 3 and -4? It's kind of the center, right? Yeah, Julian?
Why do you replace D with 6?
Because we want the points that are at equal distance. This is the distance 6 from the center.
So it doesn't have to be the diameter.
No, D stands for distance, like in the distance formula. Yeah. So in our formula we had x plus 3 and we had y minus 4. So plus 3 and minus 4. How are those related to something we had before? It's the opposite, right? We had -3, 4 as our center. So our center is always going to be in here. It's going to be, instead of -3 and +4, we had +3 and -4, right? It's always the opposite there. So this creates our equation of a circle. And some of you guys might remember this from geometry. You should have talked about it in geometry. Jacob, what are you doing back there? So it's going to be x minus h squared plus y minus k squared. You have a fun calculator. You're just calculating some random stuff. All right, so we get that. Okay, do you guys remember this from geometry? Have you talked about this? Some of you guys are in geometry right now. You never talked about the equation of a circle? Yeah? Okay, so number 1, it says, write the equation of the circle with center of 5, -2, and radius 8. So this is phrased exactly like that last one, but I'm not going to do all that work to get to it. So now that I have this equation, it's going to be really easy. Because this is going to be my HK, my 5, -2, and my radius is going to be 8. So all I'm doing is I'm replacing in my equation of a circle. Goodness gracious. So I'm going to have x minus 5 squared plus y minus a -2. So minus a -2 will create plus 2 in there, equals r squared, 8 squared. So I'm going to have x minus 5 squared plus y plus 2 squared equals 64. Some of you guys will be able to jump to that last step right away. I recommend that you do. Don't write out all that work for just that. Does that make sense? You're just plugging and chucking, putting those in there. All right, so number 2, it says write the equation of the circle with center of -4, 11. So that's definitely our HK. But this time we don't have our radius. So we don't know what the radius is. So there are different ways that you can do this. So you could sketch it out. But I don't always recommend sketching things out because sometimes, like this one goes up to 11, which is kind of high. 1, 2, 3, 4, 5, 6, 7, 8. But what if I gave you something that went up to like 173? Do you want to sketch that out? No. All right, and then it contains the point 5, -1. Okay, so that was our center, and it contains this point. Do you guys want a story about circles? I had a professor in college. His name was Dr. Stegemuller. We called him Steggy. Have I told you this? Dr. Stegemuller? I don't know. So Steggy was, I don't know how to, he was like 75 years old, very tall and skinny. He was a runner, which I appreciated. I liked that he was a runner. But he used to wear what I would call flappy shorts. Like, you know how runners wear those shorts that are a little too much? He used to wear those when he was teaching, and he used to like stretch while he was teaching. So it's really awkward. But Steggy, I loved him. He was a good guy. He had something fun about him. I do not have this trait, but he was an amazing circle artist. I did tell you this? So he could draw circles, and he would do competitions where he would go to like Las Vegas, and they would have circle drawing competitions where he would put this here, and he had a very southern accent, so he'd be like, well, it's more like here. It's like straight out from his arm. And be like, all right, here we go, here we go, here we go. And then Steggy would do this perfect circle. So he would do it like super fast, and be like, all right, here. And it would be perfect. Mine is never perfect. I can't do it. So all my years of teaching that, I still can't do it. I can't even do it on this little machine either. I can't draw my perfect circle. So anyway, going back to this. Maybe we should have a circle drawing competition someday. We'll do that. Okay, so if I want this radius, I could just find the distance between those 2 points, right? So that's one way we could do it. Okay, here's another way. Do you guys remember when we did equations of lines, or even when you did this in Algebra 1? And you had like y equals mx plus b. And let's say we knew a point that was on the line, but we didn't know what b was, the y-intercept. Do you guys remember how we would temporarily plug something in for x and y to find what b was? We can do that here as well. So you can set up your circle equation, and you can replace your h and you can replace your k with what they're equal to, but we don't have r. And we need to find r. So my h and my k are going to be that -4, so I'm going to have +4 there, and -11 there. But temporarily, I'm going to plug this in for x and y. So I'm going to plug in 5 and -1. So you can do it that way as well. It's just like the distance formula, really. So I get 9 squared plus -12 squared equals r squared. So I get 81 plus 144 equals r squared. So r squared equals 225. So I'm guessing some of you guys know the square root of that. Yeah.
So then, well, the square root's 15, but do we know that that point is do we know
Yeah.
that's the radius?
It says it contains the point, meaning the circle contains that point. It's there
So it could
on
be
the
inside
edge.
the circle.
No, it's when you say the circle contains the point, it means it's on the outside edge of the circle. Yeah, it's not within the boundary. I don't know how. When we say contains, it means, yeah. I know, it's kind of weird. Yeah, Greta?
So would we put plus or minus 15?
We could put plus or minus 15, but you actually don't need to. And on the recent homework I graded, I haven't passed it back actually, but I need to input it. But some of you guys put plus or minus for the distance formula, which is fine, but if it's a distance, we just do the positive version, right? Yeah.
So 15 is the answer.
15 is our radius. So then when we say find the equation of the circle then we go back to where we were, and we plug in our h was -4, so plus 4. And we plug in our k was 11. And then our r was 15, so r squared is 225, right? So sometimes when you find r squared, just leave it like r squared. She inputs all my grades, isn't she nice? She helps me out. All right, so I end up getting 225. So do you see what I'm saying? Sometimes when you leave it there, you're good. Don't like, if it's like square root of 80 and we don't want to find like a simplified thing, just leave it as 80. All right. Jacob, what do you have on your calculator? Is it a game? Are you playing a fun game? I'm going to play games. All right, so a tangent. Do you guys remember a tangent line? Did you talk about this in geometry? Yeah, so a tangent line is a line that just barely touches the outside of a circle. The stem tangens is Latin for touches. So it touches the circle. And it's going to touch that circle on exactly one point. It's not going to go like through the circle. Does it make sense? Okay, so something that's special in geometry about a tangent is that at its point of tangency, if I draw a line to the radius, this angle that's created is 90 degrees. Okay, so that's special with the tangent. So it creates a 90-degree angle. So number 1, it says write the equation for the line tangent to the circle at the point 2, 5. So we have to know what this picture looks like, kind of, in order to get this. So if I have x squared plus y squared equals 29, can you guys tell what h and k is when you have x squared plus y squared? Yeah, it's 0. Do you guys see how that's x minus 0 squared plus y minus 0 squared equals the square root of 29 squared, which is, I'm just writing 29, but the radius is square root of 29. So if I was sketching this out, it starts at 0. And I don't know how to sketch out square root of 29. Okay, but I do know that it goes through the point 2, 5. So we're going to have some kind of circle. Man, here we go, here we go, here we go, right? I can never do it. It's like so awkward when it's like on the screen too. Nothing. Oh well, somewhat close. All right, so we want the equation of this red line that I'm drawing in. Okay. So in order to find the equation of a line, we always need like 2 points, or we need the slope and a point, right? We need lots of slope and an intercept, right? All we have right now is the point that it's going through. It goes through 2, 5. And we don't have another point. So this is where we use the tangent line, okay? So I'm going to connect the center of the circle to that point, and when I do, it creates a 90-degree angle. Okay, do you guys know the slope of this black line? I go up and over. How much do I go up and over? I go up and over 5/2, right? I count my rise over run. So I'm going up and over. So my slope is 5/2. So if my red line is then perpendicular, then what is it going to be? What's my slope? -2/5. Okay. So if I'm finding the equation of this line, then I can do that thing I was just talking about. I can do y equals mx plus b. And I don't have the b value, but I at least have that 2, 5. And I can plug in 2 and 5 for my x and y temporarily to find b. I could also use the point slope form, y minus y1 equals m times x minus x1. I could do that as well. So I get 5 equals -4/5 plus b. So I add that -4/5. So I add 4/5 to both sides. And I get common denominators. So I multiply by 5/5. So we end up getting b is equal to 25 plus 4, so 29/5. So the equation of the tangent line is -2/5 x plus 29/5. Okay? Does this make sense? Okay, So same idea on number 2.
Oh, where'd you get the -2/5?
Negative 2 over 5, whatever slope we have here, this one's going to be the opposite reciprocal. So we flip it and make it the opposite sign because they're perpendicular to each other. So you remember if you have a slope of like 2/5, you have -2/5, or -5 over 2 is the other one. Yeah.
Sorry, I'm a little confused how that multiplies to get 29 over.
It doesn't multiply to be 29 over 5. This becomes 25, and then you add it to the 4. So I did 2 steps in one there. Does that make sense? Mm-hmm. You got it? All right, same thing. Let's try it. Yep.
Why was it -2/5?
The slope is going to be the opposite reciprocal of the slope here. So we found this slope to be up 5 over 2. So 5 over 2. So if you flip your 5 over 2 over, you get 2/5, and you make the opposite sign. So remember when we talked about parallel and perpendicular lines?
Yes.
So parallel lines have the same slope. Perpendicular lines have opposite reciprocals. So if I had 7/12, the other one would be -12 over 7. So that's what I did there. All right. So same thing here. We're going to sketch it out. So my circle has a center. Can you guys tell what the center and radius is of the circle? 1, -2. And our radius is 5, right? The square root of 25. So go to 1, -2, and draw your center. And then my radius is 5, so this one I can draw. The square root of 29, I don't know, that was a struggle. How do you draw a square root of 29? So we're going to go over 1, 2, 3, 4, 5, and get 1 point on the circle. We're going to use 4 points as our guide. So I'm going to go up from the center, up 1, 2, 3, 4, 5 to get another point. I'm going to go left, 1, 2, 3, 4, 5, and get a third point. And I'm going to go down 1, 2, 3, 4, 5 to get a fourth point. Those 4 points are going to help you draw in that circle. So you just basically from your center, you go up the radius, you go down the radius, right and left the radius. Okay, and the sketch always helps on these. So we're finding the equation of the line that's tangent at the point 5, -5. So 5, -5 is like somewhere around here. So we want to find the equation of this red line that I'm drawing in. Mine keeps crossing, but you get the gist. So we're doing basically the same thing that we did on that last problem. So whenever you see a tangent line, you think, okay, it's going to be perpendicular to the radius. So draw that radius in. And I want you to find the slope going from the center to the point of tangency. See if you can find it. So we're drawing the radius in, and we're going to find that slope. So this was at the point 1, -2, and I'm moving to the point 5, -5. So when I talk about how much I'm going down and over, I'm going down 3. Mine looks like 2, but down 3 over 4, right? So the slope of this blue line is -3 over 4. You can see how I got that? So I went from a height of -2 to a height of -5, so I went down 3. And I went from 1 to 5, so I went over 4. Yeah?
It's supposed to be that the radius is 5 units.
The radius is 5 units, but that's we're not using that distance.
Well, yes, but I mean that was just.
All right, so you could do the Pythagorean theorem and get that that's 5. Is that what you're saying?
Oh, well, yes, but then I was puzzled. I guess maybe
Okay. So if we have a slope of -3/4 and we want the slope that's perpendicular to that, what slope do we have? 4/3, right? So the slope of the red line is 4/3 then. Oh man, it just stopped writing for some reason. That's a bummer. I don't know what just happened here. Okay. All right, so go ahead and write the equation of the final line then. Oh, there we go. Or not line, final circle. So I get x minus the center was 1. Oh, no, I'm writing the equation of the tangent line. I got distracted, sorry. So finding the equation of the line that's tangent, right? So you can do your y equals mx plus b if you want, or you could even do this one. Do you guys remember this equation? We did this in chapter 2, review from algebra 1. So this is called point slope form. So you could plug this in for our, not that point, hang on. This point in for our x1, y1. And then we can plug this slope in for m. So we're going to get y minus a negative 5, so plus 5, equals 4/3 times x minus 5. And we distribute, so we get minus 20 over 3. And we subtract that 5 over, so we're really subtracting 15 over 3. So your final answer, did you guys get this? 4/3 x minus 35 over 3. Did you guys have that? You could also get it with the y equals mx plus b. It's the same thing. All right, so moving on to completing the square. So does it cause fear in your hearts when I say completing the square? Are you like, oh, I thought we were done with this? It's not that hard. We can do this. Okay, so we're going to be doing completing the square a lot throughout this chapter because we're going to have special points that we need to find. Like in this case, we were trying to find the center of a circle. That's important to us if we're sketching it, right? So the way we're going to set up all of these throughout this chapter is we're going to do x's together, we're going to have our y's together, and then we're going to have equals the number on the other side. So we're first going to rearrange all the items in our equation. So I'm going to have x squared plus 6x under the x's, and I'm going to have the only y value, y squared there. So I'm just moving things around. So x squared plus 6x, y squared, and my number, if I subtract the 7 over, so or add the 7 over, I get 7. Okay? So we first rearrange. Now we're going to complete the square, and I'm going to have some kind of number here that's making that a perfect square that I'm able to factor. Some of you guys might know that number already. Do you guys know it? Yeah, Jacob, what'd you get? Do you know the number? 3 squared, right, so 9, yeah. So it would factor into x plus 3. Okay, this y one though, for this example, not all of these, but for this example, I don't need to do a little box with that. Do you guys see what the k value of our vertex is? Like if I talk about h comma k, what's the, not vertex, center? Do you guys see what the k value of that center is? It's 0, right? It's like y minus 0 squared, so we don't have to do anything there. All right, and then equals 7, and then we're going to have to balance our equation, so whatever we have in that red box, we're going to add over here as well. Okay. So if you don't remember complete the square, it's fine. We take the b value, and we divide it by 2, and we square it.
Wait, what's the?
Like a, b, c, like quadratic formula. So it's the number in front of your x. So we're taking that number, and we're dividing it by 2, and we're squaring it. So sometimes I say have it and square it. So I'm going to take 6 divided by 2 squared. So 3 squared is 9. And that's the number that I'm going to add here and here. And I do it on both sides of the equation because otherwise I'm not keeping that equation balanced. Okay? So now I have this x squared plus 6x plus 9. Well, x squared plus 6x plus 9, if you try to factor it, it factors into x plus 3 times x plus 3. That's why we call this completing the square, because this is now x plus 3 quantity squared. Do you guys see that? Plus y squared equals 16. This is the equation of the circle. That's like our standard form for a circle. So when we have it in this form, we can immediately identify our center and our radius. And that's what our question said. It said find the center, find the radius. So our center, do you guys see it's negative 3 comma 0? All right, we switch the signs. Negative 3, 0. And then our radius is 4. Does that make sense? So we're going to do the same thing on the next one. So we're going to first put our x's together, then our y's together, and then on the other side of the equation we're going to have our number. Okay, so I'm going to have x squared minus 2x, and I'm going to have some kind of box here. And then I'm going to have y squared minus 8y, and I'm going to have some kind of box here. And then I have equals negative 1. And whatever I have in those two boxes, I'm going to have to add to this other side of the equation. So some of you guys are able to do this in your head. You're having it and squaring it. So you're taking the number in front of the x, have it and square it. Divide it by 2, you get negative 1. Square it, you get 1. So 1 goes in this box. Take this number, negative 8. Divided by 2, you get negative 4. Square it, you get 16. right? If you can't do that, just write it off to the side. Negative 2 over 2 squared is negative 1 squared, which is 1. So 1 goes in here. And then this one, negative 8 divided by 2 squared is negative 4 squared, which is 16. So 16 goes in here. So then we have a 1 and a 16 on the other side as well. So we do this for a reason, because now x squared minus 2x plus 1 factors. So it factors into x minus 1 times x minus 1, right? So I'm going to have x minus 1 squared. And then the second part, so this y squared minus 8y plus 16, that factors as well. Okay, and that factors into y minus 4 squared. The numbers are always what you had before you squared. You see that's negative 1 squared and negative 4 squared. Right, so the numbers, like this number was right there, and this number was right there. So if you aren't sure. All right, and then equals, so I'm going to take my negative 1 plus 16, and I get 16. This is my equation of my circle. Can you identify the center and the radius? Okay, so what's the center? 1, 4. What's the radius? 4. Yep, you got it. So 1, 4, and 4. Comma's kind of crazy. All right, and the last one, this is kind of like what we did on your homework. I think there's 2 more actually. So it says find the equation of the circle that has a diameter with endpoints given by negative 1, 2, and 3, 2. You can sketch this out. We had this actually yesterday, or 2 days ago. I don't know when I saw it. Yesterday, right? So basically, you don't have to sketch it out, though. If these are your endpoints of a circle, and the endpoints of a diameter, and you're trying to find the center, how do I find that? Yeah, do the midpoint, right? So I'm going to do the midpoint formula to get my center. And the midpoint formula, if you remember, is the average of our x values and the average of the y's. So if I have the numbers negative 1 and 3, I add them together and divide by 2. And I have 2 and 2, I add it together and divide by 2. So your center is 2 over 2, which is 1, and 4 over 2, which is 2. And then your radius involves the distance formula, right? So let's find the diameter first. Remember, I don't like to use a value if I've found it, just in case it was wrong. So my diameter is going to be using this distance formula, 3 minus a negative 1 squared plus 2 minus a 2 squared. Actually, they're straight across from each other. Maybe it would have helped if I sketched it. Do you guys see how they're at the same height? So they're directly across from each other. So their distance goes from negative 1 to 3. It ends up being 4. So 4 squared under square root is 4. So that means our radius is what? 2. Yep. So your equation of the circle then is x minus 1 squared plus y minus 2 squared equals 4. Okay, and then the very last one's super quick, don't worry. You guys are panicking because it's so close. Well, we actually have time, don't we? Yeah. Got a double today. Lots of fun. All right, so this one really quickly. So find the equation of the circle with center of 4, 5 that's tangent to the x-axis. Yeah.
Oh, but isn't the radius 4 because 4 squared is 16?
The radius is 4. What are you saying? So 4 squared was 16.
Because like you add 3 and 1, so that equals 4.
Oh, yeah. So that's the diameter, though. That was our.
Oh.
You get it? Okay. So then I divide it into 2. All right. So I have 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. So it says find the equation of the circle with a center at 4, 5 and is tangent to the x-axis. These are really weird questions. Okay, the best way is to sketch it. So if you guys are like, oh, I'm artistically challenged, I can't do this, at least try to sketch it out. Okay, so we have 4, 5. And what we're saying is that we're tangent to the x-axis. So it's just barely going to touch that x-axis. It's not going to cross it. So if I have a circle that just barely touches the x-axis, are you able to find the radius?
Yeah.
What is it? 5. It is 5. Do you guys see it? It's just the distance down to that x-axis. So now we have our center, HK, and we have our radius, which is 5, so we put it in our formula. So we have x minus 4 squared plus y minus 5 squared equals 5 squared, so 25. And that's our answer. Okay, does that make sense? No? Where did I lose you? So tangent means touches. It just barely touches the x-axis. Yeah.
Shouldn't the distance be 4?
The distance be 4?
Because it's 4 to 0.
Nope, the distance to the y-axis would be 4. So if I said tangent to the y-axis, then it would be 4. But I said x-axis. So yeah, that's why the sketch really helps, because it depends on which axis you're going to. All right, let me pass out your homework.